today's lesson we're going to continue on with some more stoichiometry problems and learn something called limiting and excess reagents, or they're sometimes called limiting and excess reactants. So to get things started, we're going to do a little mini lab, thought lab, to try and get the idea of what a limiting item is. So the situation is, imagine that you're in the business of producing cars. You have a simplified equation for making a car down below here in blue. One car body, 4 wheels, 2 wiper blades gives you one car. Yes, there's lots more parts missing, but we're just simplifying it for example. Let's say you have these many parts. 35 car bodies, 150 wiper blades, and 120 wheels. How many cars can you make with those 3 things? So take a minute, think about that, pause the video if you need to, and then we're going to check our answers here. Okay. So hopefully you've had a moment to think about how many cars you can make with the following parts. So now let's analyze one at a time. So what if we looked at car bodies first, since it's the first one here. 35 car bodies is what we have. And we're going to divide it by how many car bodies you need per car. 1 car body per car. Now mathematically that's nice and easy. 35 divided by 1 would give us 35 cars if we used up all of those parts. But we need to check the other parts and see how many we can get. So next, let's check the wiper blades. If we have 150 blades and we divide it by how many we need per car, we need 2 wiper blades for 1 car. So when we divide that, we get 75 cars. 150 divided by 2 is 75 cars. So right away we can see there's a discrepancy here. There's no way we can make 75 cars, because if we use up all the car bodies, the maximum is 35. But now we've got one more to check. Let's check those wheels. So 120 wheels. And we know you need 4 wheels per car. So 120 divided by 4 gives you 30 cars. Okay, so looking at this and answering our question, how many cars can you make with the following? You can make only 30 cars. Once you use up all of the wheels, you'll have 30 cars made. You can definitely make 30 cars out of the car bodies available and definitely 30 out of the blades, but you'll have some blades and some car bodies left over. So let's try and look at a couple follow-up questions with this activity, and hopefully that'll help us understand a little bit more about what's going on. So we've already done question 1. How many complete cars can you make? We said that that was 30. Which item limits the number of complete cars you can make? So which one's the restricting item? Which one's going to limit the number of cars? Well, we just talked about that. That would be the wheels. It makes the fewest number of cars. So once we use up all the wheels, that's it. Which items are present in excess amounts? That means leftover. So we know there will be some car bodies left. And we know there's going to be some wiper blades left. Last question, how much of each excess item remains after the reaction or after we make all of the cars? So we know there's car bodies and wiper blades left. Let's go back to the previous page and take a look at our calculations and see what we can come up with. So for the leftover amounts, if we only make 30 cars, that means for the car bodies, there's only going to be 5 car bodies left. It's a 1-to-1 ratio, 1 car per 1 body. 35 minus 30 would leave me with 5 cars worth of car bodies, so that means 5 car bodies left. But if I look at the blades, we said you could make 75 total cars. How many blades worth of parts are left per cars? Well, we had 75 cars. If we use up enough parts for 30 of them, that means 45 are left. But remember, this means 45 cars. How many how many blades per car? Well, there's 2 blades per car. So that means if we double this, we would have 90 blades left over. So even though this isn't exactly chemistry, what we're doing here, we're dealing with car parts and blades. The idea here with identifying a limiting item or an excess item is the same thing what we'll do with chemical reactions. How did we figure out the limiting item? We divided by the number of parts required for each car. Those numbers were the numbers up here in our equation. These, if it were chemical equation with chemical formulas, these are coefficients. So once we identified the parts that we had in the right units to figure out the limiting item, we divided by the coefficient. And we'll do that exact same thing when it comes time to doing a chemistry problem in a few minutes. So let's now switch gears and start to think about chemistry. So what's actually going on with chemistry and limiting an excess reactant? The limiting reactant, we're going to abbreviate that for reference as LR, is a reactant that's completely used up in a chemical reaction. It's going to run out first. Different reasons why it can run out. You might not have enough, or there's just not enough available, or if it's something happening in the environment, you use up everything that's there, and then that's it. Remember, this in our little activity were the wheels, just to make some reference. The excess reactant is going to be a reactant that remains after the reaction's left over. There's leftover parts. If you have multiple reactants, more than 2, you could have several excess. But in our activity, these were the blades, and these were the car bodies. One important thing to note, and hopefully with some of the practice that we'll do this week, you'll see this in action. Once the limiting reactant is completely used up, no more product will be made. It doesn't matter how much of the other reactant is still there. No more product is produced, and the reaction stops. So now what we're going to do is actually try the same type of thing, but with a stoichiometry problem. So a lot of this problem is going to look similar to your stoichiometry. So if you need your stoichiometry roadmap handy, you can definitely grab that. But the part with the limiting reactant is the new part mixed in. So here's our question. We've got 17.5 grams of carbon reacting with 225 grams of sulfur dioxide. We have a balanced equation, always check. And we're going to do two things. Find the limiting reactant and calculate how much carbon disulfide is produced. So, like all of the other problems, I always suggest rewrite your equation, and let's try and organize our data before we do anything else. So there's my balanced equation, and I'm going to write down what I have. 17.5 grams of carbon and 225 grams of sulfur dioxide. Okay. There's two parts to this question. One part is finding the limiting reactant, and the other part is finding out how much product is produced. This part, part B, we'll do obviously second, but if we want to write this in here, this is what we're trying to do for part B. Now, where this is different from previous stoichiometry problems is the fact that you have two different masses to work with. You might not have noticed this when doing stoichiometry problems so far, but you would have only had one mass, maybe mass of carbon and find the mass of a product, or just the mass of sulfur dioxide and find the mass of a product. Here you've got two masses. When you have two masses, this changes the problem. Which one's going to run out first? Is there a limiting reactant? Just like we saw with the thought lab with the car parts, we needed to figure out which car part was going to run out first, and we said that was going to be the wheels. And then the wheels told us how many cars we were going to make. Here we have to do the same thing. Is the carbon going to run out first, or is the sulfur dioxide going to run out first? And then whichever one runs out first is going to tell us how to do part B, how much of our product we're going to get. If you remember back with the car parts, to figure out which one was going to run out first, we divided by the coefficient. We're going to do the same thing here, but first we have to change our masses into moles. Because coefficients are in molar amounts, this is not the same type of unit. So, part A, we want to find the moles for our reactants. This is the first thing that we need to do. Okay. So, same way as we've done many times before, 17.5 grams, and we're going to use our ratio with molar mass. Molar mass for carbon, 12.01 grams, and we're going to get about 1.457 moles. Then we're going to do the same thing for sulfur dioxide, 225 grams times 1 mole, and we divide it by its molar mass, which is 64.07 grams, and we get about 3.512 moles. We don't want to round too much here, but we don't want to leave out some important information. Okay, so now we have our units in moles. This is where we're going to divide by the coefficient, just like we did with the car parts. We divided by the coefficient in the car parts equation. Here we're going to do the same thing, but with our molar amounts. So there's a 5 in front of the carbon. We're going to divide its molar amount by 5. With the sulfur dioxide, there's a 2. We're going to divide this amount by 2. So go ahead and try that in your calculator. When you check, what we're looking for is the smaller amount. Remember, with the car parts, we looked for the fewest number of cars after we divided. The fewest number of cars was 30. Here we're looking for the smallest amount of moles. So when we do this for carbon, we get about 2.914. And here we get about 1.756. So which one is smaller? This is smaller. So this tells us this is going to be our limiting reactant. For reference, if we want, this one over here is larger, and this is going to be our excess reactant. So now we've answered part A of the question. Find the limiting reactant. So find the number of moles of each, then divide by the coefficient, and whichever value is smaller is going to tell you which one will run out first. So carbon is our limiting reactant, part A. Now let's go on to part B. So part B, find out how much carbon disulfide is produced. This part of the question is exactly the same idea as stoichiometry, but the one trick here is you have to use the limiting reactant to answer part B. If you don't find out which one the limiting reactant is and you guess wrong, you'll get the wrong answer. So you need to find limiting reactant first. So let's go ahead and try part B, and we'll set it up just like our other stoichiometry problems. So let's make a note here. To find the mass of carbon disulfide produced, use the limiting reactant. So let's rewrite our balanced equation. And we know this is our limiting reactant. We have its mass, but we've already done a mole calculation for it. So we don't need to do that mole step again. We're going to use that number we have. Which number do we use? Use the one before you divide. We don't want to use the 1 divided by 5 here. We want to just use this one here. Okay? So we're going to use that 1.457 moles. And now we're going to set up the rest of the problem like before. So how do we get to the mass of carbon disulfide from the number of moles of carbon? We've already done step 1 in the stoichiometry map because we have the number of moles of carbon. Next thing, we would need to find the number of moles of carbon disulfide. This is going to be the first step for part B, and we know we need to use our mole ratio here. We've done that many times by now, so hopefully that should ring a bell. And then the next step, we have to find the mass, and we're going to use the molar mass again. So those two steps here are exactly the same as stoichiometry. So let's try and solve those ones together. So number of moles of carbon disulfide. We've got our moles of carbon multiplied by the mole ratio. Carbon disulfide on the top, there's 1 mole. 5 moles of carbon on the bottom. And you should get that number 2914 moles. We still have to do this step with a mole ratio because the number here, the coefficient for carbon disulfide, yes, it's 1 here, but in other situations that mole ratio might be a 2 or a 3 or something else. So we have to do this step again from scratch. So that was our first step. Now we have moles of carbon disulfide. Let's find the mass. So 0.2914 moles. And we're going to multiply by the molar mass, which is 76.15. That's 1 carbon and 2 sulfurs per mole. And then we end up with about 22.19011 and some change there, grams. And then, like always, we're going to round to significant digits. So if you take a look back at the question, think about how many significant digits you need. For this one, you should have 3. So 22, the last digit here, we need to round up to 2. So there's a problem with chemical equations, chemical formulas, and limiting an excess reactant. So I'm going to get you to try one out now and see if you can answer part A and part B, and I'll walk you through the answer. And then there's one twist with part C, which is on the next part of the lesson. So pause the video here and see if you can first solve the limiting reactant and then do part B, figure out how much of that lithium hydroxide is produced. So pause it, try it, pause it along the way if you need some help getting started, but I'll walk through this full answer with you next, and then we'll do part C together. Okay, so let's take a look at part A. Part A, we need to find the limiting reactant. So here's your balanced equation. Taking a look at what we're given, we have 2 masses. Which one's going to run out first? So we need to find our limiting reactant. We said the first step, if you have 2 masses, make sure you find the moles. And then once you have the number of moles, divide by the coefficient. So our molar mass of lithium nitride and molar mass of water, we get our 2 molar amounts. And then we're going to divide by the coefficients. So here, no number, it's just number 1. And that 3 here goes with the water, which is down here. When you check your answer, you should find that the water here is your limiting reactant. Let's move that up a little bit more. It's got the smaller amount down here, so it's going to run out first, and there's going to be some lithium nitride left. It's your excess reactant. So this number up here, this number of moles, tells us that water is your limiting reactant. So that's the answer to part A. Now again, if you haven't tried part B yet, this would be a good time. Pause the video and try out part B. If you've tried out part B, keep going. We'll take a look at the answer now. For part B, we're going to try and find the mass of lithium hydroxide. So you need this number of moles up here. It's got some stars in yellow beside it. That's the number we need to do our calculation. This dividing step here is just a check. These numbers don't work for the next step, so don't use the ones after you've divided by the coefficient. Use the original amount of moles. So that number up here, if we reorganize our data and set it up like a stoichiometry problem, is this number down here. We have 0.3219 moles of water. How much lithium hydroxide do we have in mass in grams? Same 2 steps. Find the number of moles of lithium hydroxide using your mole ratio, and then convert that moles into mass using molar mass. And again, part B, the steps here are just the same 2 steps as you would see with your stoichiometry problems from our previous lesson. So our mole ratio here is 3 to 3, or 1 to 1, so you'll notice the number of moles don't change. And then when we convert that to a mass, this is the mass of lithium hydroxide, and round to 3 significant digits, you should have about 7.71. Part C with this question is a little bit different. So let's take a look at that one. How much of the excess reactant remains after the reaction is complete? So just like the car part activity we did at the very beginning, we were able to figure out which one were in excess, which were our car bodies and wiper blades, and then we were able to figure out exactly how many car bodies and wiper blades were left. We're going to do the same thing here, but we need to find out how much. of the excess reactants left, but this time it'll be in grams. So for reference, let's rewrite our equation. And we remember figured out this is our excess reactant, lithium nitride, and this is our limiting reactant. And for reference, let's put our given masses in. This is what was given to us at the beginning of the question. Okay, so basically what we're trying to find out now is a calculation to see how much is left. So what are we going to do? We know all of the water is going to be used up, all of the 5.80 grams. But how much lithium nitride is required to react all of that water? That's what we need to do in terms of calculate. How much lithium nitride is required to use up or react all of that 5.80 grams of water? So mathematically, we need to do this. So we're going to do two steps, and it's basically like stoichiometry. First, how many moles of water do we have? 5.80 grams times 1 mole, and we get 18.02 grams for the molar mass. And this is about 0.322 moles. This is the same calculation that we did in the first part of the question. So you could even just copy that answer in there if you wanted. But now we want to find out how many moles of lithium nitride would be required to react with this one. So we're going to do a mole ratio between water and lithium nitride. So how many moles of lithium nitride are required to do the reaction? So we take our moles of water and do our mole ratio. 1 mole of lithium nitride for 3 moles of water. So we're dividing that number by 3. And we get about 0.107 moles. So this tells us if we want to react all of the water, 0.322 moles of water, we need 0.10 moles of lithium nitride. Now we want to change that back into a mass and see how that compares to what we started off with in the question. So third step, and you'll notice again, these are just like stoichiometry. So the mass of lithium nitride required to use up all that water, we're just going to take our moles and we're going to multiply it by the molar mass of lithium nitride. And if we round to significant digits, you should get about 3.73 grams. So this number here says if I want to use up all of the water, all of the 5.80 grams, I only need 3.73 grams of lithium nitride. That's what that means. Let's make a reference to this. How much lithium nitride do I have? Well, I have 4.87 grams of lithium nitride available. That's how much was given to us for the reaction. So I have a bigger number, I use up a smaller amount. How much of that excess is left over? Last step here is just to do a subtraction. So leftover excess reactant, which is Li3N, I had 4.87 grams. I subtract 3.73 grams, and I get 1.14 grams left. So this calculation here at the end is the equivalent of what we did with the car parts. How many car bodies were left over? We said 5. How many wiper blades were left over? We said there were 90. Here we've got 1.14 grams of our excess reactant left over. Part C is definitely the most challenging type of question. There won't be too many of them, but if you can do part C, then you really understand how to do stoichiometry and apply it to different problems.